is around that area. And this is we check the obstacles. In the GMR, I'm still using the Python 2 and we will convert it to 3. Okay, guys? Okay, we get this. Okay, let's... Hello guys, welcome to Rifki the Cyber. So today we are going to discuss again another satellite things. I was discussing about the Iridium, Inmarsat, etc. Okay guys, so today we are going to go back again to the geostationary satellite. In this case, the name is Thuraya. Thuraya is using the GMR1, geostationary mobile radio interface in this case. It's using the standard HCTS 101376. If you are the guy that like to see the standard international regarding with this GMR1 radio itself. Okay guys, this satellite is located geostationary, located in the 36,000 kilometer above the sky or 35,000 kilometer above the sky. Yes, same distance like Inmarsat in this case. Unlike Iridium, it's not geostationary. It has their own orbital. It's only 780 kilometer. But this one, the geostationary one, the position is quite far, 36,000 kilometer, okay guys, or 36,000 kilometer above the skies. Okay guys, I would like to disclaimer with regard to the manage the expectations. Number one, the Thuraya that is going to cover here is because I'm located in the city that supposedly is covered by the Thuraya 3, and somehow as per April 2024, due to the payload failure, the Thuraya 3 is stopped operated in this case. So unfortunately, my region is not getting covered the beam that actually usually is served by the Thuraya 3. But okay, moving forward. So later, to manage these expectations, so my area right now, in this case, I'm going to use Thuraya 2, which is Thuraya 2 actually is not part of this region. So supposedly, the location of the city that I'm resided right now, supposedly it won't get any beam, right guys? But the fact is, at least I'm not getting any beam, but at least I can get like a spillover of that beam itself, or I can get like a breadcrumbs of that signal itself, guys. But of course, it's quite struggling to do this. So sometimes in the 1 hour or 30 minutes, 1 hour or 1/2 hour, I only get like 1, 2, or 3 package in this case. But I think it's okay, guys. I was just going to show it to you how to set up this one. And number two, because I'm using the Thuraya 2, which is the beam supposedly is not here, the locations is quite near to the horizon, okay, like elevation like 18 degrees, something like that. This is something that I need to manage the expectation from you as the audience. Will we get this kind of this signal or not? Later, we will using the satellite finder. Please note also, if you can see in the satellite finder, it doesn't mean seeing in able to direct the antenna towards the satellite is not the same we get the signal. Because yes, that the situations, that is the position of the satellite, but the satellite actually beam to the some another place, maybe in the Europe and other case. Okay, guys? So this is to manage the expectations itself about the Thuraya 2. But of course, there is something great things and the new things in this video, guys. So the challenge is using for the GMR1 is GMR1, I think, using the GNU Radio 3.7. So I will using the RTL-SDR with the bias T. Now is our part to see how I set up the antenna. For that one, I need to go to the outside of my, go to my garden area. I'm going to show it to you about this elevation things, yeah, the horizon things, and why I decide to put my antenna in the second floor. You're gonna see my setup later, guys. Okay, guys? Come. Okay, so look at my cat. Is there? They are fighting. Sabana. Don't fighting. Okay, guys. So what we're gonna do? We are going to get where is this position of the satellite. Okay, guys. But the issue is, like I told you, beside the Thuraya 2 doesn't have any beam, but also the elevation of the Thuraya 2 is in the 18 degree, which is actually very near with the horizons. It's quite difficult, guys. This is like try to capture the satellite, but the satellite is almost sunset or satellite set. You get what I mean, right? If the sun going to set, this is like a satellite almost set, something like that. So come here. I'm going to show it to you. So this is the okay. Come. I'm going to show it to you. This is the satellite. So we choose the Thuraya. Okay, Thuraya to here. So this is the location here, and we check the obstacles is going to be the around 7 or 18 degree, which is actually is quite difficult, right? There are so many barriers, which is my plants, etc. So what I'm gonna do, I'm going to go there in the second floor. So we will go to the second floor, no worries. Okay, I will put the antenna there. Okay, although again this is 18-degree elevation, which is quite difficult. Okay, let's go there. Okay guys, before we going out, so this is my station, guys. So this is my station. My laptop have the Ubuntu GNU radio, which is a quite higher versions. But no worries, we will troubleshoot that one. Okay, guys. And I'm using RTL-SDR. So this is the RTL-SDR here. But before that, let's come. So this is the antenna, guys. The antenna is going to that directions actually. So what we're gonna do? We are going to facing this. Let's check. Actually, I already set this one. Okay, come here. Okay, this is the seat. The is around that area, and this is we check the obstacles. Okay, so that is the, if you see from here, so this is the position of that satellite itself. Of course there are some plan, etc., but as I told you, this is the elevation 18 degree elevation, which is quite difficult because it's already near to the horizon, which is actually is very near already to the horizon. So it's quite. And this one is the coaxial cable. Come here. So this coaxial cable is connected to the RTL SDR. I put another cable here. So I just plug here. Finish. So we don't switch on anything from here. But I think this is my cat. Then here. Sorry, Sabana. Because I'm going to lock this. Otherwise you cannot drink your water. Oh, no. So this is my cat. The name is Sabana. Okay. Okay, guys. Okay, guys. We back again to the studio. Rather than lot of chatty, let's go test this one, guys. Okay. I already prepared the GitHub for this as a guidance for this one. So this is my GitHub. Thuraya GMR1 satellite with OsmoGMR. Of course, we will using the OsmoGMR. So you can see from this one, the most important that I would like to highlight this one. You can read everything so on from here. Managing expectation, as I mentioned it to you, right? Elevations, and supposedly we don't get anything. But we get it actually, but it's very minimum. And then after that, RTL-SDR, we are using the RTL-SDR version 3. And those antenna is the built-in LNA antenna. I explain it to you in the Inmarsat part 1. Okay, guys? Ubuntu is okay as long as you can install the lib Osmo Core and Conda itself. When you can install Conda, you can install the GNU radio. Coax cable, you can see already. Satellite. And this is the downlink because we are going to sniffing the downlink. This is near the horizon, as I told you before. Okay, guys? You will see this 100 of CRC1 failures because sometimes even in the 1 minute, even in the 1 minute or sometimes 2 hours, you can get only 1 packet, 2 packets itself. Okay, guys? And this is the prerequisites, the essential everything. So on, we will test it later. No worries. Okay, git clone, etc. So on. What about this? And this one is the reference. If you need some reference here, and if you want to support me, buy me coffee. On coffee, you can scan this one. Okay, guys? I think we are good to go to do this one. So let's start again, guys. Okay, let's start. Okay. So I think this is already in my. I think I'm going to open some windows here. Okay, now I just open 3 windows here. Okay. We will go to the desktop. And I think I already prepared this check install. I already copied this shell script and just running it. Okay, look at his one. This is the prerequisite, right? Build, git, autoconf, automake. But the most critical is, actually they really need this one, okay guys? But the most critical is this one. We are going to install this one, okay guys? If you have the missing package, you just need to running whatever it is that this is how you do it. But since I already have it, then it's okay guys? So I think I don't need to run this one because libosmocore is already written here. This is the version. Now what I'm gonna do, I'm going to git clone from this Osmo itself. But if you notice here, this is not just only git clone from the branch of the Sylvain Live. So Sylvain is actually the one who coding this one with the team, guys. So credit to him, right guys? To the Sylvain, the owner of this OsmoGMR script in this case. What we're gonna do, we just need to git clone this. I prefer to use in the documents. Clear. Is it empty? Okay, empty. I just put it here and then run. Just git clone like that. And then cd OsmoGMR. And then auto reconf DOS-fi. And then, of course, it's just running the configure. Okay. And we just make here in this case. Well, some people after this running the make install, but I just want to run it in the directory itself, right guys? So let's verify with this. Can we access this one? We just run this one. Okay, we can access, right? It shows to you how to the argument itself and how we running this. Cool is there. Okay. And the second is we just need to see if this is existing or not. It's existing, okay? But we cannot run it, okay? And also we have this in our, oh no, I think it's in the SRC. So I think we have live here. This is live, but currently because we don't get any very full of the actual beam is not really work in this case. Okay, the GMR need GNU Radio 3.8, but unfortunately we have here is actually 3.10. Okay, guys. How I check the GNU Radio? So I will just make it clear to make it easy. So how we can check that one? We just using this command GNU Radio config -versions. Okay, this is 3.10. It won't work for this OsmoCom for the Sylvain OsmoGMR, guys. It require you the 3.7, but actually it's work for 3.8. Believe me. But we need some tweak in this case, okay guys? So no need to, change to the 18.04 or something like that is overkill. So what we're gonna do, we are using the Conda in this case, okay guys? So this is how to install the Conda. I will not repeat, you just look at the Inmarsat part 1 in this case, okay? So what we need to do is just using this one. So I'm going to create this GMR environment, okay? But because I already create this GMR environment, I will just create new environment, GMR1 environment for in this case, okay guys? Using the Conda forts. Why 3.8 Rifina 3.7? So what we're going to do like this, we are using 3.8 and then we will convert those GMR, RTL-SDR, we convert this from Python 2 to 0.3. Okay, this is Python 3, right? Right guys? But the GNU radio that we install is Python 3, but still still compatible with the same API or the same core for the GMR. And so we are using in the GMR is still using the Python 2 and we will convert it to 3. Okay guys? So from 3.10 we just using the 3.8. We make it a downgrade via the Conda. Actually not downgrade it because we will not jeopardizing the actual from the host of the GNU radio itself. This is isolated guys. Okay guys? And we will upgrade those Python 2 to Python 3 for the GMR multi the SDR-RX itself, okay? So this is how we do it. So I just say yes before. Okay, done. Now we enter to this Conda activate GMR1 environment. Okay, it's already created this. And we install this 2.3. What is it? 2.3 is actually to convert the Python 2 to 3, okay? I already installed that. Sudo install, blah, 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 etc. And I think we don't need to go to this one. We just if you ever there is something problem, just only need to copy this again, but we don't need to do it because we don't tweak anything, right? So we're just running this one. Finish. Now this is supposedly should be work. Okay, it's work. Okay, guys. Before it cannot be work with this case. This is done. This is done. Now I'm using the RTL RTP blah blah blah. Okay, guys. Maybe you think, Rifki, we just running this with the argument RTP, something like that, right? We don't need to using the RTL, TCP, etc. Why, Rifki, you using this one? The reason why I want to use this RTL TCP, because in the RTL TCP, there is a debugging logs that saying, hey, the bias T is already on. I need these confirmations. I need these verifications to make sure that the bias T is really on, guys. That's why I'm using the RTL TCP in this case. So I think I'm going to open again another shell in this case, just only for okay, activated. See, bias T activated in the GPU. But this is not yet. That's only. This is it say that okay, if you're using this, it will be bias T enabled. But somehow I still want to use this. So this is like this. Please switch on RTL RTP using this IP and live in the 1234. So it will be accessed by access with any radio software. If they want to enjoy this RTL-SDR, want to use this RTL-SDR, it can go to this IP and using this port. And this is the port itself, 1234, and this is the bias T, okay? But that's not all. When the OsmoGMR running, it will tell us also, okay, this is the bias T is also running. Oh yeah, guys, because what happened is, due to the beam is not come here, I just try to find at least where is the most strength signal in this case, guys. You can using this RTL power from this 1525-1560 because this is actually the range of the downlink of the Thuraya itself, and we can get the CSV file, and from the CSV file you can play with the Excel. For example, okay, which one is the reddish dB that strongest one, and you just choose that frequency, and that frequency you can convert it from that frequency towards the RFCN. In this case, I got this one from the sweep. It's around this frequency, and this is actually the most near RFCN is actually 540 in this case. Okay, guys. Now we are going to running this. Okay, so this is actually the guy who's sniffing this one, the one that we put the effort to make this is compatible, the GMR RX SDR, and using this sampling, the bandwidth is L-band because it's the L-band itself. Frequency is this one, and actually this one is the RFCN, and this is the gain. I think this is the maximum gain if you want to use the bias T, and this is the IP of the bias T that we just try before, okay, and put argument bias 1 inside of this argument, so bias 1. So I will just copy this one, this, okay. Okay, you look here, eh? Okay, I will just enter. I will just put it one by one, side by side. Enter. Boom. See? Boom, 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 boom. And then after that, there is a bias T inside of this one. Okay, guys? So this is currently is running. I like to do the monitoring like it's like this. OsmoGMR. We're just running this one first. Okay, I think sleep 7 is too much, right? So we are going to sleep 12. Okay, we just wait, guys, until we can get something for decoded in this case. Okay, guys, because this is still 0 in this case. Okay, we just wait. Okay, guys, we get the 3 package. Okay, the 3 package, we got it here. We shouldn't get it, guys, because, you know, as I told you that we are not part of the coverage optimum beam spot of the Thuraya 2 in this case. Okay, we are going to stop this one. Okay, we are going to stop this. I will just Ctrl-C this. And after that, we're just going to... I will just using this sudo tshark, okay? We will sniffing this. So whenever this is decoded, it will be reflected here, okay? I think this is the one, this one. See? I'm using this. Okay. Yeah, here. I will just stop this. So, okay, this is what GMR1, air interface, etc. Okay, guys, let's copy this one, guys. Okay, let's copy this. This is using this. We're just using the Thuraya.pickup. Thuraya 504.pickup. Okay, let's start with this. Okay, I think this is done. So we just need to copy from this one. Workbench. Okay. I will just copy this from my Ubuntu. Okay, great. Okay, we get this. Oh yeah, guys, don't forget to subscribe, switch on the bell, and share this channel to others. Okay, let's open this. Okay, this is, it say that GMR1, air, etc. Right, guys? Actually, the good news is actually in the Wireshark, they already have the GSM type, which is GSM type is used also for the decoding this GMR1 itself. So it supposedly is compatible. Yeah, of course, we cannot decode this one. But I'm going to show you what is the other pickup that I already got last time. For example, this one. I was able in the ERFCN 1066 before. Still operated, right? That means, right? In the 1066, actually, it's not part of this one. See some information too in this case. This one also. See, we get the cell reselections in this case. You look at this one. This is GMR1, BCCH is already here. There is a cell bar, cell is not blah blah blah, etc. And of course, there are some SB reselections, etc. here. So that is, guys, how I managed to tweak the GMR1, so it's able to use the isolated GNU radio without I saw someone that using the old one, the old operating system, which is overkill. You're just using the new one. If ever you don't want to breaking the installation of the existing GNU radio, the new one, the 3.10, you just go to the Conda installations and then go to the Conda itself and then install the GNU radio from there. So it will be isolated and using the GNU radio itself in this case. And I told you also, I think that GNU radio, although we are using the 3.8, etc., of course we still need to convert the Python to the Python 3 script of that GMR1 SDR receiver in this case. And I think I mentioned also some disclaimer to manage the expectations in this case, like we supposedly not receiving the beam, and of course the challenge about the horizon itself. Sorry. Okay, I think this is sufficient. As I always say in my other previous video, keep learning and stay humble.